Since we just spoke about the progressive subsampling size string option, even if the first string option listed is the progressive subsampling pattern, we will go down to the progressive. Let me find it. Okay, here it is. Is listed after the progressive true or false, which enables the progressive render sampler. So since the value 0 or 1 disable this feature, we will input a value or 2 or even 4 to make an extreme block of pixels. Should be big block of pixel. Let's see how render. This is just to show you the pattern. Let's see how it looks. You see? You see the pattern of the block of pixel. Let's see after if will be refined after subframe. No, it's very rough until the end. Please note that I set the max sample to the progressive max sample to 100 for these scenes, and later you will see that for the erase scene I have to set to the max sample string option to the value of 1000 to get more quality in the image. Array need I guess 10 times more the value than the standard Maya mental array scene, where we use only the environment IBL and PR string options. I think we can stop it here around frame 25. As you can see, the block of pixel which we set to the value 4 is just for the start, let's say for the first 10 frames, subframes, 10 or 20 subframes, because after start to be smooth again and appear the dots like before. So this is important to remember. Anyway, we reset to the default value 1, which disables this feature. You can also set the value 0, because both of the values reset means disable this feature. Since we are already near the end of the string option, as you can see, and the next string option is the progressive subsampling mode, which is set to detail by default. So you see the last string option is the array, so we are near the end. Let's see from the main PDF what says again about the progressive subsampling mode. So let's open again the PDF. This is still the progressive subsampling size. Scroll down and here there is the mode, which can be set to sparse or detail. It controls the appearance of subsampling pixels which are not rendered yet. The default is detail. If set to sparse, then unrendered pixels are set to black, and this produces image with missing pixel, giving the impression of noise. So, since that by default is set to detail, the progressive subsampling mode, let's open the Maya scene one more time. And let's input the value. We replace detail with sparse. Let's see what change. I think will be a subtle difference. Let's see. Maybe we should enable again the subsampling size, but first let's try to render. Output window, of course. You see subsampling size set to 1. Actually, I don't see much difference from before. Maybe after the first few subframes we will see the difference, or maybe we just should increase the subsampling size first to see if this solution is more rough than the detailed one. Now let's see, we are on subframe number 7. Let's go to number 10 just to compare a little bit the result. Or better now, better to go a little bit further so we can compare with the previous one. It's just how the pixels are displayed, sampled, okay, sampled is the better word, and to me looks even smoother than before. This is my feeling, so let's see, stop the render, and let's check how it looks compared with the previous one. Actually the detail, maybe we stopped the detail before, but I don't see this much difference. It's just I guess that this progressive subsampling mode is just how the pixels are interpolate each other. Means they say from the online help that when it's set to sparse, then unrendered pixels are set to black, and this produce image with the missing pixel, which giving the impression of noise. To be honest, it looks quite similar to me, so to try one more time we increase the size first of the subsample. So let's just input 4, or maybe 2 is better because 4 is too rough. So just input 2 in the subsampling size and render one more time, and then we go back to the detail subsampling mode, and let's see the difference. Okay, these are the block of pixel, now is 2 by 2, and you see it's like a grid. Actually it looks like a grid of pixel, and let's see the output window what say. Frame 4, let's go to frame 10, and then we compare, we will stop the rendering, and we will compare with the subsampling detail mode. Let's see how long will take. Now we are close to subframe 10, and we stop the render like this, and we just change sparse to be detail. Let me check the, yeah, because you cannot always remember all these definition Maya and mental rate terms. Let's hit one more time render, and let's see what happened. Output window. We are near to the end of the presentation, because next we will check the array, which have no option. There is only on or off. So you should enjoy, because we are really the end of the presentation here. Let's go to subframe 10. The main difference that I see is that before looks more like a grid. So let's interrupt the render, and let's see if it's true what I feel. Before looks more like a grid, like actually, wait, 0.57, 0.56. Actually the difference are very subtle. Okay, this and this. Very subtle, means it's difficult to say. Anyway, it's just a sampling mode, so you just test by yourself and you will find the answer. And I think we check the other progressive sampling string option now. Now let's scroll up again in the string option attribute editor, and mode we see already, size we see already. Just input again the size to, or maybe leave it to 2, so we see a little bit better the differences. And let's go up progressive through, we don't need to see. Final gather normal tolerance is not concerned the mental rate 3.8 feature. Is a new feature of the final gather, which is implemented now in the new Maya 2011 version. And honestly, I didn't use much, so we can skip for now. And let's go up to the important one. Let's go back to check the subsampling pattern. which is set to scatter in our scene. Let's open the PDF one more time and let's go to see what say about the subsampling pattern, control in which sequence the samples are computed. The default is scatter, which is our. If set to linear, then pixels are computed in a line-by-line order within a pixel block. If set to scatter, then the pixels are rendered in a quasi-random order. So since that we have the input by default the scatter value, we will input the linear value and let's see what change, and hit render. Let's see what happened. I remember that I tested these features already, and I remember that there was a grid pattern, not with some of these options. Some looks really like a grid. Let's go on to check how looks the pattern. I think I have to increase more the sampling size to see better the differences. I definitely have to increase the sampling size. So just let's see how many subframe already rendered. Let's go to 10 just to be sure. If we will feel no difference between the linear and the scatter, means that we have to increase the subsampling size. So let's interrupt the render and input again the scatter. Let's see. Enter is confirmed and render one more time. You see, I could use the button, but I prefer to use the drop down menu. Is more easy for you. And I am also used to, by the way. So let's check how it's rendering the image. As you can see, the first subsamples are very coarse because we set the subsampling size to 2. And let's see with the scatter if there is any difference between the previous linear option. So this is 5. Let's see now with subframe 8, 9 and 10. Let's stop. I have the feeling that we will not see much difference. Yeah. Let's see also if I don't want to focus in the render view, but what we will do is just go down to the size and increase even more. Let's see if this helps to see the main difference between these settings. Render again, but the size influences mostly the start of the sampling. As you can see, now the start is very coarse, but we still don't see the coarse, the grid pattern that I used to see when I test these features. Let me see how many frames are rendered. Already 16. Possible. 17. It's very fast. When it's coarse, it's very fast. When the subsampling size is increased, it's very fast. And let's stop on 20. Let's say 20. One more second. Okay, now we can stop. Let's scroll down again in the string option and input the linear, correct? Because I think we have the scatter one, yeah. So just try one last time. Linear and enter. Let's see if something changed. Output window. Never forget the output window, always keep it open. Okay, the first samples are very coarse like before, and I still don't see the grid appearing. I guess that we should test this on a very higher resolution, not 800 by 600 or something like this. And let's see what happened now. 18 With the subsampling size of 4, the first subframes are super fast, as you can see, and it go refining step by step, and then the speed is average, like when you use the other mode, or when you put the size to 1, to the default 1. Let's interrupt the render, and here, stop the render, and we will check the remaining string option settings of the progressive rendering. Since this part of this section of the progressive rendering sampler settings is a complete failure, I have to accept this, because I cannot show you the difference, the grid pattern and these kind of things. I just was trying to change the light mode of the environment lighting of the IBL from light to approximate, which is anyway useful for you to see. This is what we just rendered before, and this is what I just did now. You see the different distribution of light, and you see, yeah, it's completely different. When it's approximate, it's much more for preview. As you can see, it's not neat, you see, but with detail, with light, sorry, it's a much more concentrate the light contribution. This is just a note, but I think that, let's open the PDF 1 second. I think that to see the different patterns, first you should render at higher resolution, and with the render view panel completely enlarged to fit to window. And the second thing, I think this is like you can do by yourself, it's not very important. You can make combination, like for example, you can choose sparse, and for the progressive subsampling mode, and choose and try with linear and scatter, and do the same with detail, and input detail for the progressive subsampling mode, and try how looks different with the linear and the scatter option for the progressive subsampling pattern. I think you can do it by yourself. Now I just would like to scroll down before to show you the array scene, which settings are important, and we discussed already about the settings. The minimal samples, as I told you already, leave it to the default, and doesn't change much. It's just about when the progressive rendering will abort the rendering and will stop. But the important is the max samples, the number of samples per pixel to stop progressive rendering and array. Please note that in the scene that we just used, both of the scene, means the masterclass CM and the previous masterclass string, both use the max samples value set to 100, because with this, as I say before, when you use only the mental ray 3.8 IBL and PR string options, 100 should be more than enough. Plus, don't forget that we are using, not in this test right now, but in the scene use all the other mental ray features like global illumination, final gather, importance, irradiant particles, and whatever. So 100 is more than enough. Let's scroll down a little bit more, and the time we spoke already is in seconds, so you just input whatever in second, after how many seconds you want that the progressive rendering stops. I repeat, I prefer to stop the progressive rendering using the max samples, the progressive max samples value. Is much more neat as a solution. And then back to the progressive error threshold, I will repeat one more time. This is a quality, it drives the speed of the rendering as well, because it sets the quality of the contrast exactly like what I showed you before in under the quality tab. You remember we spoke many times about this. Here is set to 0.1, but if you set to the same value 0.05, like I say about 10,000 times in this presentation, quality will increase and render time will increase as well.